Okay, so Rainforest, your first problem or Smith? Click here to see the lesson. Click here to see the data sheet. Vocabulary we need to talk about. Finite difference. Finite difference is the differences of the consecutive outputs. Common ratio is the ratio of consecutive outputs. A data list of a list is the Ti-Nspire function that returns the difference list. Recursion is a method to create a list using an initial value and then defining the next term based on previous terms. Okay, let's take a look at the table. There's the tables that we have to analyze. And here's our objective again. Here we'll use the first and second differences as well as common ratios to determine the data provided to represent a linear, quadratic, exponential growth model. You will use a graphic calculator or other graphic technology to create a graphic model of the data provided as well. You take a graphic model and make predictions that data represents. So here's the links that I've already provided to you. Let's move away from there and look at the data that we have in hand. Here it is. Let's you could lose at a calculator. Here this has already been set up. So what your goal is to recreate something like this that you can change the data of. Pay note to the columns, headers, x, y, dy, dx. And notice that dy is the change in the list B, which is your output, because y is your output. Delta list, notice the lowercase delta, Greek letter delta, that's delta list A, because A is where you have your input. DDY is the change in the list, change in the output. So that's delta list of the delta list, which would be just the delta list of C, where I put my outputs. And C ratio stands for common ratio, and I abbreviate that. And basically, that's a recursion. This is using press escape. This is not showing how it's done, but I'll erase this and start from scratch and show you. Also, you should be able to graph this and match the model that works. So that's how we're going to use the technology. Let's start it from scratch. So let's go back home and create a table, list and spreadsheets, and label these accordingly. X for the, well, hold on. We're going to do new document first. So go home, press 1, and say, no, I don't want to save it. And we're going to add a list. And X, press tab, Y, press tab, dy for the change in the output, dx for the change in the input, ddy for the change in the output. That's known as the second difference. And then com ratio or common ratio put together. And that's what I want to look at. And last, let us put model. C-O-M-A-R-A-T-I-O, com ratio. Okay, so model. Model is where we're going to write our function based on what we saw. Now, at this point, I would save this. So press doc and file and save as. And I would put my name. So I'm going to put my name as and my period. And the unit I'm going to use this for. It's a unit 4 tool. So, saving it, and there it is. Okay, give me a moment. Okay, hold on. Let me pause and discuss. Okay, so let's go pick up the data. We have our columns. Let's review x, y, dy, dx, ddy, and common ratio. So let's get the data. Let's get some data here. So we minimize this like so. And we pick up this data. 1, 6, 11, 16, 21. What was it? 1, 6, 11, 16, and 21. Now I need the other data. Who has it? Can you just read it to me? 1, 36, 120. These look familiar. 256. 441. These are squares, right? 6 times 6 is 36. 11 times 11 is 121. I think this is going to be quadratic. Just guessing. But I'm not supposed to know. Okay, right here, we're supposed to put equals, and then we can type D E L T A L I S T, open parentheses, and then I got to think, which one do I want, the input or the output? A or B? B. There it is. Yes. And then just click your cursor here. Oops. Click your cursor here, click in there, and then you type in, get in there, and automatically the DX comes out. Type DELTALIST. Now we're changing the X. We want to change an X, press A, press enter. Then go to this one, and we're going to go delta list. Also, you could do the menu. You could do menu, data, list operation, and then difference list. And that types it for you, but I think that's kind of hard because you have to remember where it is. So the change in the change would be the change in list C. And let me pause it for a moment. So let us press enter here. And yeah, okay, that should be done. Now the common ratio, see here, don't go there, go one down. This is recursion. This is equal to the previous term. Where do I want to get the from the outputs? My outputs are in column B, so I want to get the control divide. Control divide. I want the ratio of the next term divided by the previous term. So B2 times B divided by B1, and I want to multiply this by 1.0, so it'll convert to a decimal. And once you do that, you click back up here, press Control, and in the middle of the touchpad, there's a little arrow with a little shiny thing. That means click. So I'm clicking that. You see that nothing looks like it happened, but it did. What you need to do is go down. But because I did it like that, I have to do it again. Control, click, and then push on the down arrow. And you see that it goes to there. Go up one more. I could try go there. Nothing's going to happen to a certain point. And there they are. Those are the common ratios. So what I'm looking for, you can see the formulas. That's B2 divided by B1 goes there. Then B3 divided by B2. Then B4 divided by B3. And B5 divided by B4. There's, oh, and I needed to go further down, looks like. I should have. I can't divide that. So I could try one more. See if I get something. And I get nothing, because that's all I can divide. The last piece of data is on B5. So that makes sense that B5 divided by B4. There's no B6, so I can't do that. So there's the common ratio. Is the common ratio the same? No. So this is not exponential. Is the first difference constant? No. Is the second difference constant? Yes. So this is quadratic. That's the rule. And now I can run the regression here, and I can ask the computer here for the model, or I could try to guess it if I had some information. What I like to do is press menu, the home key, then look at the data, and look at the shape as well. This is X, and this is Y. There's my data, and now I'm going to do menu, as we've done in the past, analyze it. I could plot the function. I can either do 4 if I know, or 6 if I'm just going to ask the computer. And I'm going to show quadratic, and there it is. X squared is basically the model. So I can go back on 1.1, and I can type the model and say this is A power 2 squared. Enter. And that matches my model specifically. I can add a column here, residual, where that would be equal to G minus B. And G minus B is the difference between my model and the actual output. And you see that there is no difference.
So it's G minus B?
Yeah. Here we go. So what we need to do now is look at this plot. See that it matches real nicely. And I could do menu, and I could also do analyze and plot the function. And had I just said x squared, notice that I put x instead of a because x, this is a function x. And there it is. It fits perfectly. That's the other thing I can do. Now, what you need to do is go to the other things. Look at table B. So we've established that A is just the squares. What's B? It looks like the domain is the same, but the output is different. The output is 3, 18, 33, 48, 63. I need someone to read that for me. What was it? 3, 18, 33, 48, and 63. Okay, now what I like about this calculator and this tool is, check it out. I know right away the first differences are constant. This is going to be on your test. You got to understand this. If I see the first difference is constant, what does that make me think?
It's all linear.
It's linear. Now let's look at the differences on the x's. 5. Tell me, what is the change in y or the change in x? You might know it as rise over run. If something goes up 15 every time this one goes up 5, what's the slope? What's 15 divided by 5? 3. I think I should use 3 times x as my model. And now I'm going to see if I can find the y-intercept. I don't see the y-intercept on the table. I could try to figure out, or I could guess and check. So right now, I see that the common ratio is not constant, so it's not exponential. And I see that my model is not working, but I think it's 3x. So this one, not 3x. In this one, where's my input? A or B? A. Okay. Does that work? And what are the differences? Oh my gosh, the difference is actually 0. So I matched it exactly. I don't believe it. 318. Hold on. Wow. It was just 3 times the number all along. 3 times 1, 3. 3 times 6. Oh wow. That was too easy. So one more to do. Right? Give me the data for table C.
3.
Where? Is it the same domain? 3?
27.
27.
Okay.
243?
87.
28?
No, I'm 21.
21? 87?
19, 68.
19?
19, 68.
6, 8? 3. Okay. Class, take a look at the, let's take a look at the difference in the y's. Is the difference in the y's constant?
No.
Is it growing?
No.
Is it growing? Yeah. It's increasing, right? It's increasing pretty fast. So that's a hint that it's exponential. Yes. Okay. We're on C. So what is it? Uh-huh. Uh-huh. Okay. Okay, yet that does not change the output and that analysis, but it does change the step. All right? And you'll see how that affects that in a moment. Now let's look at the change in the change. It's also growing fast. So no matter how many times I try to subtract the differences, I cannot use finite differences to find that. That tells me that it's not going to be linear, quadratic, or cubic. It's going to be, hopefully, maybe exponential. And look at that. We have a common ratio of 9. Excellent. And our model, of course, is not going to work. So let's change our model. Okay, so I think I should use 9. But wait a minute, before I do that, what is my first output? What is my first output? I don't remember. Let's take a look. My first output was 3. So I'm going to go to my model. And I'm going to put 3 times 9 to the power of x. I mean a. Okay, hold on. Okay, so we're going to see what happens when I type this. And did we get the right numbers? Obviously, no, because that's supposed to be a 3. So what I'm going to do is I'm going to remind you of the step. See this 2? So what you do here is you have to go here to the x, and I'm going to delete the x. I'm going to put a, in parentheses a, divided by 2. And see if that helps me. And maybe that was wrong, because I got 9, and I was supposed to get 3. So what did I forget? Let's see. Let's pause this for a moment and think. Okay. So what we have to do is shift it. This starts at 9, but we have to shift it. So previously, I had this. So that's 981, but this sequence starts at 3, and this is 1. So what we need to do is go here to the model and shift the x minus 1, because that's where the x starts. If it started somewhere else, not at 1, that's my first. The 1 is my first input, and 3 is my first output. This has to be 0 for this thing to work, to give me that point. And I have to divide by the 2 to get the next step right. And let's check it. There it is. Look at the differences. They're now 0, and now I match. Right?
Yes, sir.
So, good. And these are not actual data, apparently. These are fixed examples. The data, you'll have a little bit of more variance. All right, thank you. That ends the lesson. No. Okay, so what do we turn in? Let's turn in... Okay, we're going to turn in this screenshot here, this screenshot, and then this screenshot, and then we also want to turn in this model, but this model is no good. Let's change it to menu, analyze, and it'd be cooler to have you actually doing a video of this, if you could. And then I'm going to say that this is x, and this is y. Hopefully it'll look better. And that parabola, we need to turn it off, because obviously it's not quadratic. So regression and hide the quadratic. And that looks good. It's 1 times 3 to the x. They simplified it. They have a different model. Okay. See how, notice that that's different than my model. My model's a little bit different, but it will simplify to that, because I use transformations. So let's screenshot that, turn that in, and that's all you have to turn it in. Thank you.